Greetings. Welcome to the Brain Gauge channel. I'm Mark Tomadol, and I guess I've made most of the videos on the Brain Gauge channel. And what I want to do is right now give a brief introduction to the Brain Gauge as well as the Brain Gauge channel. Let's just knock the Brain Gauge channel intro out of here right now. It is meant to describe the brain gauge, everything about it. There's a lot of different short videos, a few long videos, but basically we want to look at different topics. What's the science behind the brain gauge? What are the tutorials, the practical side? How do you run it? How does the analysis app work? And how do you do that? How do how is the brain gauge used in case studies? So all these things are different sections. Take a look at the Brain Gauge channel. I invite you to take a look. And, if you see things that are interesting you, great, make comments. And if you'd like to see another topic, just ask. I am perfectly willing to make a video. If you ask a question, I'll do my best to answer it. And I'm probably going to be teaching my very last course this fall at University of North Carolina, and after that, I will, but after that I will continue to take questions from non-students because that's the enjoyable part of the work is discovery and understanding new questions. So anyway, I invite you to ask questions, and I will either come up with an answer or make up an answer, one way or the other. Anyway. And let's start the introduction. Okay, so really quick, what's the brain gauge? And the brain gauge, take my word for it for a little while, it's an objective way to measure and track brain health. And if you really want to see all the videos that prove different aspects of it, that's great. Or you can just take our word for it and we'll follow along. So basically, this is the brain gauge. And you got two probe tips here. They vibrate and activate, nerves in your fingers, which project to places in your brain. Those places in the brain, the important part of this, all of the history of this is that's what we studied for 25 years before we ever started doing these kinds of studies, before we built the first prototype. We did mostly work studying cortical activity in primates. But now, then we switch into now we do all human work. We do research around the world with the brain gauge and many, many different research institutions. And we also work with clinicians around the world as well as individuals who are just tracking their own brain health or tracking their own brain function with the brain gauge. This plugs into any laptop or computer. It's fairly low cost, and the whole motivating factor that we had when we first built this was to do something that would help people. That was our whole point. And the reason we thought we could help people is we thought if we could build something that would track brain function at low cost, then it would give people insight whether their treatments were working, whether they were recovering from something, whether, doing some kind of changing their diet, changing their lifestyle actually was improving their brain function. And, or does the brain need to be changed? I mean, in other words, has you fallen off the wagon and things gotten a little bit gone downhill? And is it time to just intervene? Is it time for an intervention? But anyway, we'll talk about that a little bit in this talk. But anyway, those are some of the questions. But anyway, why would you want to use a brain gauge? Why would you want to track brain health? And at the top here, I have, if you don't measure it, you can't manage it. So besides my role at University of North Carolina as faculty and teaching, and now I'm down to teaching, as I mentioned, I'm going to retire, as I'm also help run the company at Cortical Metrics that distributes the brain gauge. But I also am a farmer. And this was in one of my farming journals. And this makes so much sense. Everybody measures whatever they're doing. Farmers manage their yields, and they measure their yields as well as keep track of what goes into their soil, how much water, how much precipitation, what was the end product. But, along those same lines, we measure absolutely everything that we do. And competitive athletes, measure how far they can do. A lot of people measure how far they walk every day with a walking app. But people know exactly how far they've gone. They know how many calories they take in, but they do all kinds of things physically. But when it comes to brain health, they just kind of shake it off. No, why bother? I mean, and yet your brain is one of the most important things you have. If you're using your brain to make its own measures to perceive itself, it doesn't really work that well. If you look down, if you check if you break your arm and you look at it and say, "Yep, compound fracture," you can look at it and tell. You're not using your arm to make that assessment. You might not be able to move it. You're using your brain. Now, if your brain's not working right, and you're depending on your brain to tell you that things are working right, then you've lost half the battle. So basically, measuring it is a way to manage it, and that's how do you recover? How do you manage recovery and treatments? So the first question I'm going to tackle: how does the brain gauge work? I mentioned we vibrate these probe tips on the brain gauge that activate nerves in the fingers, which project to places in the brain that we studied quite a bit. And what we do is when we deliver these stimuli, these vibrations to the skin, to the two adjacent fingers, we ask a series of questions. Now, the stimuli and the patterns of stimuli that go to these fingers can be quite complex. However, what we do ask is what we do say, well, the questions we ask whoever's taking the test are quite simple. Which is bigger? Which lasted longer? Which came first? And basically what you're looking at is the way we ask these questions, they are all mechanistically targeting. We're targeting different mechanisms of information processing. These are mechanisms like lateral inhibition and information processing speed. I mean, there's several different mechanisms that we target. And if you want to find out more about those, we've got videos on each of these different mechanisms and the science behind them. Now, but these questions are targeting fundamental building blocks of information processing. For example, you may have taken a test for, say, memory. Well, lateral inhibition and plasticity are building blocks of memory. And so that's what we're looking at, the fundamental building blocks of things that you're looking at. Now, this test is delivered in the same manner that an eye exam is. That's why this eye chart is here. The test starts out easy, and it gets harder and harder and harder. But that's one reason the eye exam's here. But you can find a threshold on this eye chart fairly quickly by going down, as we can find thresholds fairly quickly. We can find out what those metrics are fairly quickly. Now, another reason this eye chart's on here is that the whole principle of this is that while the eye chart finds, how well your vision is working, these tests are doing the same thing. We're trying to figure out, okay, how well can your brain work? How well can it focus on a particular point? And that's what some of these tests do. They really hone in on specific points and try to figure out these different mechanistic ways to target these different neurological mechanisms. But basically, when you do this, you can probe different aspects of neurofunction. And that will give you, and you're probing it through somatosensory system rather than just asking someone, how do you feel? Because that's really a crappy way to find out if somebody's brain is working. Okay, so what do the brain gauge measures look like? Now we've given all these tests, and then these tests we spit out these labels on each of these tests that are mechanistically related. And this is just a commonly used test battery. It takes 15 to 20 minutes, depending on how fast you take it. And then we display it in what we think is fairly intuitive manner. In intuitive manner, I mean, well, green is good, red is bad. That's simple. Yellow somewhere in between. So what you want is to have all green. And we basically, this is called a bar chart, and we can also plot it in a radar chart. Some people like the radar chart. I prefer the bar chart. That's just me. And these things are scaled from 0 to 100, 100% being your best score. And if it's down here, if you get a 5, that's not a good score. So it's pretty intuitive and pretty straightforward, and it's scaled to thousands of normative data points that we've collected over the years. Okay, so first thing you want to do is compare scores across a patient's history or your history. And so let's say you got a concussion, and we're looking at day 1 through day 14 of a concussion. Day 1, your scores aren't that great. Day 14, they look really good. Again, it's fairly intuitive, very easy to follow this. All right. But thing is, we don't generally just show the bar chart. What we usually show is we take this overall score down here, which is a composite of all these scores. And all these scores are targeting different mechanisms. And that's their goal, is that we're targeting different aspects of brain processing or brain function. And then we're basically adding them up, crudely speaking. And then you get an overall score, and then you can see the overall process. And in this case, treatment was started here. There was very little response to treatment. Sometimes treatment takes a while to get going, and then treatment kicked in and started working. The data analysis app organizes all your data, stores it forever, and basically what you do is you select your patient ID. Generally, it's an eight character alphanumeric, and that you enter. But in this case, I just put in the labels patient 1 through 10, and patient number 4 was selected. This is what that person looks like. This is their raw data. The raw data is what goes into these values here. And some people get really good at looking at raw data, and there's different levels of expertise. But for most part, you don't need to look at that. You just need to look at the raw data and see what the overall general trend is. And so the purpose of the brain gauge is to help optimize brain function. And just to give you an idea of what we mean by optimization is we want to maximize the tuning curve. We want to find out where on the tuning curve something is. And so think about it in terms of dosimetry. How much of something do you take? And the best example for this dosimetry that comes up to mind, most people have experience with caffeine. And let's say you wake up early in the morning and you feel kind of sluggish, and if you were to test, your score would probably be down kind of low. But if you were to take a little bit of caffeine, maybe that's all you need to wake up, and your scores would actually start getting better. And but as many of my students tend to do, they want to experiment and say, well, no, if 2 shots of espresso is good, 8 shots is better. And 8 shots is not better, because generally that's going to roll off and you're going to start doing worse, because too much caffeine can really mess you up. Okay, so let's see how does this help in well, we would call it research, but basically think about it. If you're a clinician, you are doing research. If you're an individual looking at your own brain function, you're doing research. Just because you're not in an academic or research institution does not mean you're not a researcher. Every patient is a research subject, unless you have some inside knowledge that every patient's identical or every person's identical. And basically what you see, you start in this case, this person started treatment, and then when treatment was stopped, things rolled off. So in this case, they probably should have resumed treatment at some point, but they didn't, because treatment was stopped for whatever reason. This kind of thing happens, but it does give you insight into how long to keep treatment going. And that's kind of an important thing. Or if you're slowing treatments down, and a lot of times treatments start out at twice a week and then once a week and then go to once a month. Sometimes maybe you need to test people just to see if turning down the treatment frequency is actually a good thing. And maybe you just need to see, is it time for a tune-up? All right, let's do a quick case study. And this case study is in press at Journal of Science and Medicine. But let's just take a quick look. In this case study, this patient started out here. Scores are not great. And the last test was here. Scores look really good. And at this point, that person, the subject, was basically their treatment was slowed down because they were doing so well on the brain gauge scores. Now, let me tell you a little bit more about this study. Started out as a 9-year-old boy who with ADHD, and he really wasn't doing all that great. So his test scores weren't great. One treatment, all of a sudden, he was doing really good. And then the next couple of treatments, he wasn't doing so hot. Overall trend is good. Now, overall trend is what you're looking for. But what were these other time points where things happened where he didn't do so well? Well, I mentioned he had ADHD, missed a medication here. Then he had a visitation, unsupervised visitation from his mother for a week. And after that, he wasn't doing so well. Then this is a domestic disturbance. And then after that, he started doing much better again. Week 4, another visitation, unsupervised visitation, a little bit shorter, but didn't last long, but he still recovered, started doing better. Number 5, he was at a sleepover where he lost. Well, obviously, as a 10-year-old boy, you're not, when you have a sleepover, that's just code for staying awake all night. And reduced treatment was started here after he got much, much better. So this is pretty good considering, pretty good considering the circumstance. You have to take into account all the factors, and the brain gauge just gives you more information. Is the trend still going up, even though certain things are going bad? Okay, let's take another look at another patient. This treatment, this was a 56-year-old female with a high stress lifestyle. She had eating disorders and she was excessively drinking. And the patient was concerned about being stressed out and losing her memory, as well as having some anger management issues. So her score was really pretty bad when she started. Immediately started treatment. Treatment got much, much better, and she ended up doing exceptionally well. This just sort of gives you some encouragement how well the brain gauge works and how sensitive it is. So a lot of people don't think that stress and anxiety is going to impact brain function, which is ridiculous. It does. Stress and anxiety have all kinds of downstream effect. Well, I mean, that does impact cortical issues, and if you want, and the brain gauge does pick up on how on these things. So, for example, stress causes impact on cortisol. Cortisol levels have an impact on GABA. GABA has a downstream effect on several of the brain gauge scores, a direct effect. We know that from years of experimentation. Look at another case study. Now there was no treatment in this one, but it's an acute concussion study, sports concussion. And here was where the injury was. And this is where the first measurements were. The first time they were measured. Generally, there was a 24-hour stand-in period where you don't do anything post-concussion in NC2A rules. And then you see there was a slow recovery. This was pretty bad initial scores. And so it took a month to recover. So almost a month to fully recover and fully clear. Now, some of these numbers I put on just to give you a reference, because this is, out of 400 concussed subjects that we compiled from this one site and did averages across different things. yeah, this person did clear here, and this was physician clearance. But over here, this is where, when we looked at a lot of different subjects, this is where they were on average cleared by the physician. And number three, on average, that was where they cleared impact. So generally, in general, most of the subjects in these studies that we've seen, not just us, we published and other people published, people clear impact, which is an online cognitive test for concussion. They clear impact day 7. So day 1, they get concussed, or they get concussed on one day. 7 days later, they clear, and that's pretty well known. So you tell me. Sometimes things take longer. Animal studies look like mild concussion or mild whack to the head takes a good 3 weeks to recover. So our data matches a lot of the animal studies fairly well. Let's look at day 2. Oh, look at this. Number 2, cleared by balance testing. So if you guys, balance testing is really, really good for testing balance. But, for testing brain function, it really stinks. That's been my experience looking at a lot of data. And this was generous. We were being very generous to say that this is where they were cleared by balance testing. On average, between days 2 and 3 post-concussion, we see a 15% improvement over how they were pre-injury. So, the balance testing has been kind of a joke, but, if you want to talk about it, talk to your congressman and say, quit putting millions of dollars in research funding into the same people that keep doing the same thing over and over. But, that's just me. So anyway, how does the brain gauge compare? And the brain gauge is doing very well when compared to other methods. And that makes us pretty popular with a lot of people and pretty unpopular with a small amount of people. So they're not really happy that we do well, but we are doing well in research studies. And we outperform the other outcome measures for one particular reason. And that reason is that it's physiologically based and we target brain function. A lot of these other outcome measures are, we'll say neurological insult or neurological disorder specific. In other words, it'll be a questionnaire for pain, or it'll be a symptom score for concussion, or like concussion is a great example because we've outperformed a lot of concussion measures, but those are all targeted towards concussion. There's also, besides just how we've outperformed these other measures, there are advantages of the brain gauge over the other systems as well. It's got low administrative costs. That means you sit down, it's really easy to take the test or have a patient take the test. There's no pre-injury or pre-disorder baseline needed. That's kind of a concept where, at the very beginning, we were studying a lot of pain patients and we said, well, there's no way to have a pre-chronic pain measure unless you track somebody from, way before they get chronic pain. But any disorder, it's really difficult to get that pre-injury baseline. Concussion is the only industry that does that. There's no reliance on self-report. Self-report is, it might get you in the ballpark. Somebody comes in, you say, how you feeling? They say, good, bad, or in between. That's not a real objective measure. So we're trying to have we want to stick with quantitative measures. It's not language based. So a lot of questionnaires get into a little bit of trouble because they are language dependent. Ours is not. You're basically, the only language they need to know is what are the questions they're answering. And it can be in any language for that matter. It's just the questions we ask are very simple. It's agnostic, works with any neurological disorder, any insult. So anyway, let's skip on to the next slide. That's enough, that one. Okay, why the brain gauge outperforms. For this talk, I'm just going to talk about a couple of things. One is timing precision. We're going to talk about that. And one is biologically based interface. So, and the other thing, well, I will touch on this. We use a battery of tests that target multiple mechanisms. And, the more of those tests you use, the more accurate picture you get. There are trade-offs, but you can get a fairly good idea about where things are with 5 to 7 minutes of testing, or you can do a full battery that we recommend 15 to 18 minutes, or you can do even a longer battery. It takes 30 minutes. It just depends on what you're doing and how much time you have. But the CNS profile does benefit. It depends on what you're looking at. But for the most part, testing can be done fairly rapidly. Um, anyway, we're just going to touch on a couple of some. I'm going to tell you something about timing precision. So actually, I have a whole talk on this that's already on the YouTube channel, and feel free to hop in there. But basically, let's just go over what's going on here. Let's look at the history of reaction time. And what I mean by reaction time is a simple measure where if you receive a stimulus or you deliver a stimulus to the skin, and you can do this with any modality. So it can be a visual stimulus, an auditory stimulus, a touch stimulus. Don't try to do this with taste, but that's a little bit harder. But anyway, you do one of those three basic stimuli, and you deliver that stimulus, and then you respond to it as quickly as you can. That's your reaction time. And from the 1850s, there were some really, really clever experiments done, but they were done very well and very accurately, I might add. Till the 1970s, these experiments were done, and we found a lot of it. You go back and you look in the papers, and they reported for healthy people on 200 or under 200 milliseconds for reaction time. Since 1970 and beyond, those reaction times got slower and slower and slower. And I actually probably should have put the slowest ones I found on there were between 1 and 2 seconds. I left those dots off just because I thought they were so ridiculous. I couldn't even count those papers, because think about it. If you had a reaction time of 1.5 seconds, you think you could cross the street safely? I mean, that's really, really bad. But anyway, from 1970 on, we had a big, huge drift. And the interesting thing about that is, we're not the first people to report on this, but we did report on it as well. We went back and redid some of this work. In 2012, there was a flurry of papers coming out saying, "Oh, we're getting dumber as a population because look how much slower we're getting. Our reaction time is getting slower." And then there are, a bunch of other papers come out and say, "Oh no, we're not." And they had to try it. They did alternate methods of testing intelligence like IQ to see if we were getting smarter or dumber. And it turned out we weren't getting dumber. I'm not sure we're getting, I don't know. With all social media is probably making people dumber, but that's another story. Anyway, the story is people are getting dumber. People are getting slower, not dumber, rather. They're getting much slower. And so what's going on there? But there's still some down here. And in our brain gauge studies, which is black line, we're still getting reaction times around 200 milliseconds. So we actually, 1970 was introduction of the personal computer. And people started using personal computers to collect data in a very sloppy way. And the reason the brain gauge continues to be accurate is because all the circuitry is housed inside that computer mouse-sized device. And the circuitry matters. Hardware matters. We crammed about what was $100,000 worth of laboratory equipment back in the early 2000 into, obviously doesn't cost that much now because we sell a lot cheaper. Was crammed into that device, so that we can do high fidelity experiments and accurate experiments. It's really important to collect accurate data. Now, the important thing about this is reaction time is a really good measure for a lot of things. And if you're collecting, so what this means is, what these slow numbers mean is, if you were to test yourself on one computer on a particular program and then run over to another computer and test yourself, you get different answers, even if you were exact. So how would you study that? And well, how would you study different systems, and what are the contributions of those personal computers using equipment that's not a laboratory? And well, the answer is you test it with robotics and take out the human element, which is what we did. And that whole story is in another video. But the bottom line is the brain gauge has sub-millisecond accuracy in terms of timing for reaction time, and that is, and it's over 100 times more accurate than any other commercially available system. And what that also means is that reaction time variability, which is a really good measure of your ability to focus or to pay attention, that can be measured with the brain gauge accurately. Other measures cannot. Other systems can't do that. Okay, so let's look at one biologically based advantage the brain gauge has. And this is just kind of like, all right, how do we measure and look at contrast? Basically, contrast, your ability for your brain to turn that contrast knob and to sharpen up on a couple of points. Well, if you take a chunk of cortex and activate it, they'll put a stimulus here and a stimulus here, you see that very distinct activation patterns. And you see that this activity here is very sharp. And so that's really easy to tell the difference. And that's what we're doing when we deliver those stimuli to your fingers. We're just asking you like differences between those stimuli, differences between this. And well, okay, you can tell the difference there. Yeah, but what happens here? Well, over here, we mimic the neurological disorder by just turning off a little bit, just doing some of the turning off or inhibiting lateral inhibition. Well, all of a sudden, you can't see that difference. And this is what happens in a lot of things, and a lot of concussions, and a lot of neurological disorders. Let me fix my camera here. It's falling off. Get better duct tape. All right, now, so cortical activity is dependent on these patterns. I mean, your ability to make these critical measurements, or the ability for the brain gauge to make these measurements, depends on cortical activity in making these distinct patterns. And when you have these very distinct patterns in the cortex, it makes it possible to discriminate. And that's really, part of the key of this whole thing. Was designed on these patterns that we observed. We observed a lot of different patterns in the brain directly, and that's what some of these measures are dependent on. So what are our research highlights? What did we do with it? We got a bunch of publications, and that's kind of boring, so nobody wants to read those, so I'm making videos. But if you want to read them, you can go to our website and look at them. Brain gauge has demonstrated sensitivity to a lot of things. One is over-the-counter cough syrup. If you ever taken cough syrup and felt a little goofy, we can actually measure that goofiness. That's because it's an NMDA receptor antagonist, but that's another story. Drinking behavior differences in 18 to 22-year-olds. In other words, and we found that kids in that age group, if they were drinking more than if they were drinking 2 drinks per day or more, then their plasticity scores or their ability to learn went way down. Kind of a big deal. Find their cutoff. Changes in brain gauge scores with stress and anxiety. There are, like I mentioned, some people just don't get it. They don't think that the brain changes under stress and anxiety methods. But they do, it does. Response to therapy in individual PTSD, attentional deficits. We've seen differences in brain functions in many, many cohorts. Neurodevelopmental disorders like autism and ADHD, traumatic injuries such as concussion, pain, substance abuse, and cognitive reserve. We've seen changes with the aging population on and off heart medications. And we've seen reaction time at, we already mentioned we have reaction time at over 100 times accuracy of platform-dependent test systems. So thanks for listening. And if you want more information, go to our website, at corticalmetrics.com. And there are many more videos on the Brain Gauge channel, like you just watched. If you have questions, email me, info@corticalmetrics.com or mark@corticalmetrics.com. And thank you for watching.